Welcome to Topic 3, Unit 3, Double Angle and Half Angle Formulas. In the investigation, you had the opportunity to derive the double angle formulas. Now you're going to get a chance to use them. Remember at the end of this video to transfer your double angle and half angle formulas to your identity sheet that you started at the beginning of the topic. Example 1. If sine of theta equals 3/5 and theta is between pi over 2 and pi, find the exact value of the following. And it looks like we're going to be finding sine 2 theta and cosine 2 theta. And this can mean that we probably, in addition to needing to know sine of theta, we might need to know cosine of theta. So I'm going to draw a triangle. So here's theta. If the sine is 3/5, this is a Pythagorean triple, so I know the missing leg is 4. But the x coordinate should be negative in quadrant 2, so I'll make it negative. So I know that the cosine of theta is equal to -4/5. So I know the formula for sine 2 theta is 2 sine theta cosine theta, or 2 times 3/5 times -4/5, which is equal to -24/25. Part B, cosine 2 theta. Well, I can use one of 3 formulas. I'm going to go ahead and use cosine squared theta minus sine squared theta. I know that cosine is -4/5, and I'll square it, and I'll subtract from that the sine, which is 3/5, and I'll square it. That's 16/25 minus 9/25, which is equal to 7/25. Part C, tangent 2 theta. Now while we could just say that tangent 2 theta is equal to sine 2 theta over cosine 2 theta, let's go ahead and let's use the tangent identity. And this is equal to 2 times the tangent of theta over 1 minus tangent squared theta. Now if we look at our triangle above, you can see that the tangent of theta has to equal -3/4. So this formula becomes 2 times -3/4 over 1 minus -3/4 squared, or -6/4 over 1 minus 9/16. If I multiply top and bottom by 16 over 16, I get -24 over 16 minus 9, which is equal to -24/7. So in addition to double angle formulas, we also have half angle formulas, and they are listed here. What can be a little confusing about the half angle formulas is the plus or minus at the beginning. It's going to be up to you to look at the angle, in this case the sine of alpha over 2, and decide what quadrant is alpha over 2 in, and then you'll have to pick the plus or minus root. Let's see how this works. Example 6. Use a half angle identity to find the exact value of A, the cosine of 15 degrees. What quadrant is 15 degrees in? Well, that's going to be quadrant 1, where cosine is positive. So first I'm going to say cosine of 15 degrees is the same as, well, what is 15 half of? Well, if I multiply it by 2, I can find out that 15 is half of 30. So this is going to be the same as the cosine of 30 over 2. Because 15 degrees is in quadrant 1, we're going to pick the positive root, and the formula is 1 plus the cosine of theta, or 30 degrees, over 2. I'll substitute in the cosine of 30 degrees, which is the square root of 3 over 2. Now I have a complex fraction that I'm going to simplify by multiplying by 2 over 2. And now I have 2 plus the square root of 3 over 4. Now remember, you can always take the square root of the numerator separately from the denominator. The numerator becomes square root of 2 plus the square root of 3. The denominator is the square root of 4, which is 2. I know this looks unusual, but it is okay to have a radical underneath a radical. So this is our final answer. B, sine of negative 22.5. Well, first I'm going to use the fact that sine is an odd function and say that this is the same as the negative of the sine of 22.5 degrees. Now 22.5 degrees is in quadrant 1, so the sine will be greater than 0 or positive. However, we have a negative in front of this. So this is going to make it a little more complicated, but we're going to say that this is equal to the negative of the sine of, well, 22.5 is 45. So this is 45 degrees over 2. We're going to take the negative of the positive root, because 22.5 is in quadrant 1, of the square root of the formula says 1 minus the cosine of 45 degrees over 2. So a negative times a positive means it's going to be negative square root of 1 minus root 2 over 2 over 2. I'll simplify by multiplying by 2 over 2. Now I've got the negative of 2 minus the square root of 2 over 4, which becomes the negative of 2 minus the square root of 2 over 2. Part C, we're going to find the tangent of 9 pi over 8. Well, this is going to be the same as the tangent of 9 pi over 8 times 2 is 9 pi over 4 divided by 2. Now 9 pi over 4 is not on my unit circle, but it is coterminal with an angle that is on my unit circle. If I subtract 2 pi or 8 pi over 4, this is the same as the tangent of pi over 4 over 2. Now before I get my formula, I better go back to the beginning and decide which quadrant is 9 pi over 8 in. Well, since that's a little more than pi, which is 8 pi over 8, we are in quadrant 3, where tangent is positive. So I'm going to pick the positive root, and the formula says this is going to be 1 minus the cosine of pi over 4 over 1 plus the cosine of pi over 4, which is going to be equal to 1 minus root 2 over 2 over 1 plus root 2 over 2. We'll simplify by multiplying by 2 over 2. Now I've got 2 minus the square root of 2 over 2 plus the square root of 2. I will rationalize by multiplying by the conjugate. And rather than distributing the numerator, I'm just going to write the numerator as 2 minus the square root of 2 squared, and the denominator becomes 4 minus 2. I can take the square root of the numerator separately from the denominator, so the numerator becomes the square root of 2 minus the square root of 2 squared over the square root of 2. Remember that a radical and a square root cancel, so the numerator is simply 2 minus the square root of 2 over 2. I'll rationalize again by multiplying by the square root of 2 over 2. This gives me 2 times the square root of 2 minus 2 over 2, which finally simplifies to the square root of 2 minus 1. Example 7. If cosine alpha equals negative 3/5 and alpha is between pi and 3 pi over 2, or in other words, quadrant 3, find the exact value of the following. And we're going to be finding sine of alpha over 2 and cosine of alpha over 2, which means that I need to figure out which quadrant alpha over 2 is even in. If I take this equation, or this inequality right here, and I divide everything by 2, this is going to say that pi over 2 is less than alpha over 2, which is less than 3 pi over 4. So if alpha over 2 is between pi over 2 and 3 pi over 4, alpha over 2 is in quadrant 2. So in quadrant 2, sine is positive. So the sine of alpha over 2 is going to be the positive root of 1 minus the cosine of alpha over 2, which is going to be the square root of 1 minus negative 3/5 over 2. which becomes 1 plus 3/5 over 2. I'll multiply top and bottom by 5 over 5, and now I've got the square root of 5 plus 3 over 10, which is equal to the square root of 8/10, which is the same as the square root of 4/5, and I multiply by 5 over 5, and I wind up with the square root of 20 over 5, or 2 times the square root of 5 over 5. Part B, cosine of alpha over 2. Well, we've decided that alpha is in quadrant 2, where cosine is negative. So I'm going to take the negative root of 1 plus the cosine of alpha over 2. And the cosine of alpha is negative 3/5 over 2. It's going to be the negative of, if I multiply by 5 over 5, I get 5 minus 3 over 10. This is the negative of square root of 2 over 10, which is the same as the negative of the square root of 1/5. And if I multiply by 5 over 5, I get negative square root of 5 over 5. And then finally, the tangent of alpha over 2 in quadrant 2. Tangent is negative, so this will be the negative of 1 minus cosine alpha over 1 plus cosine alpha. Now, since the cosine of alpha is negative, 1 minus a negative makes this 1 plus 3/5 over 1 minus 3/5. I'll multiply by 5 over 5, and now I've got the square root of 5 plus 3 over 5 minus 3, which is equal to the negative square root of 8 over 2, or the negative square root of 4, which simplifies to negative 2. That's all for now. Thanks for watching.